Now we're going to get into the specifics of stretching itself. And remember in class, we talked about the difference between static stretching and dynamic stretching. And we said that static stretching was taking a joint to its end range of motion. So for example, my hamstring here, we're going to my end range of motion and we're feeling that stretch in the hamstring, and then we're going to hold it there. So I can't go any further down. I'm going to hold this position. And we said somewhere between 15 to 60 seconds is the general recommendation for a static stretch. Now, dynamic, on the other hand, was taking a joint through its full range of motion repeatedly in a fast or movement oriented. And that's where the word dynamic comes from. Dynamic means movement. So if I'm doing my arm swings here, I'm taking my shoulder joint through its full range of motion and warming it up. So that's the difference between the two. Now, what does this mean from a performance and or injury prevention standpoint? Well, the old way of thinking was that static stretching was essential for reducing injuries before an activity. And you maybe had coaches and or physical education teachers that told you you had to do this static stretching before you engaged in activity. Otherwise, you'd get injured or you'd get hurt. Now, I say this is the old way of thinking because recent research and or the current trend in our field is that we know that static stretching has little to no known benefits for decreasing injury risk before an activity. If an individual had a major deficiency or a major limitation with their range of motion, maybe static stretching could help a little bit for them, but for most individuals, static stretching ahead of an activity does not decrease your injury risk. Now, I bring this up because we say it probably isn't going to help you with your injury reduction, but what about performance? Static stretching before activity can actually decrease your performance. If we take an individual and we have them do static stretching and then we test their abilities, we find that they actually have lower force production, they're not as strong, they don't have as much speed or power, and their reaction time is limited or reduced. So they actually get worse in quite a few performance metrics. Now, why does that happen? There are two main reasons or two main thoughts behind it. The first one is, if you've ever hung out in a static stretch and you go into that position, when you first start doing this, you might feel a pain-like or discomfort sensation when you're stretching that muscle group, right? And your brain is getting this sensory information that's saying, hey, this is a high risk for injury, right? And that's typically why you're feeling that stretch. Well, what we know is that over time, that signal starts to get duller and it starts to go away, right? If you hold a stretch for 30 seconds, after about 10, 15 seconds, it doesn't feel as intense in terms of its pain and its discomfort. And so you're getting a desensitization in your nervous system. Your brain is becoming desensitized to that information. And that desensitization to the information can actually decrease your performance, especially in terms of that reaction time. The other element to think about is when we do static stretching, we actually are causing micro tearing in the muscle itself. So if you remember, your muscle has these fibers and they overlap something like this. And through that stretching, as we're stretching, some of those will actually tear and they'll be disrupted. And so when you get that contraction now it doesn't have as much structural integrity. And so that small damage to the muscle fibers can actually have a pretty big impact in the long haul. And so that's why we know that it can actually decrease our performance. What about dynamic stretching? Well, we know that dynamic stretching can have an impact on injury reduction. Now, if you took a group of 100 people and you have them do dynamic stretching before an activity, it does not decrease injury risk across those 100 people. So you might say that it's very similar to static in that sense, that the 100 people would not have reduced injury risk. However, dynamic stretching for individuals who have a high risk for injury, so they have like a major deficiency, maybe they have limited range of motion in their shoulder, or maybe they have a high risk for a muscle strain. Acutely, or in the short term, dynamic stretching before an activity can actually help those people reduce their injury risk or reduce the risk of a muscle strain. And so it can help in the short term with injury reduction. In terms of performance, dynamic stretching doesn't have the same negative benefits. It's not causing the same damage and it's not causing the same desensitization in your brain. And so we're not seeing that performance detriments that we saw with static. So if we think about it this way, static and dynamic maybe have a small impact on injury reduction for people who have a major limitation, but for the most part, it's going to be minimal here. but static will decrease performance while dynamic will leave performance alone. So that's why it's beneficial to do one versus the other. Now, we could also pair static and dynamic ahead of activity. And there's actually a good amount of research to show that together they can actually be a really helpful tool for decreasing this injury risk and helping with performance. And the key when mixing static and dynamic together is that static stretching always goes first, and your dynamic stretching has to be fast and explosive. So what I mean by this is if you start an activity and you start by doing that hamstring stretch, maybe afterwards, then you start doing some butt kicks or high knee drills to activate that hamstring. And you do it in a very explosive, fast manner as you're going through your dynamic stretching. That can help to do what we call a neural reset, right? Because we said that static stretching will affect your nervous system. And so the dynamic stretching in that explosive manner afterwards can actually offset some of those problems, and it can kind of reset the sensitivity of that nervous system. Well, now we need to talk about our stretch and our tendon reflex. And you'll remember that the stretch reflex is associated with that muscle spindle. So when the muscle spindle gets stretched too far, it increases your muscular contraction. The tendon reflex had to do with that GTO. And when that tendon has too much force being put on it, or there's too much torque, it shuts down the muscle that's pulling on it. So my question for you is, if I'm sitting here and I'm stretching my hamstring, am I getting a stretch reflex and am I getting a tendon reflex? Well, the first question is potentially we will get some type of stretch reflex, right? Because I'm actually stretching this muscle. Now, if you remember though, we said that to get a stretch reflex, it has to be increasing the length, but it's also the speed of the contraction. So you'll notice this when you're doing your static stretching. If you slowly go forward and you lean, you'll probably have more range of motion than if you really aggressively do that, right? Because if you aggressively do that and you're doing an increase in length very quickly, you're gonna get a stronger stretch reflex. That muscle is actually gonna contract and fight the stretch. So during stretching, especially static, we are gonna get a stretch reflex. Now, do we get a tendon reflex? Well, if you remember, if that muscle is pulling as it elongates, it's attached to a tendon. So anytime the muscle is increasing in length, we're also putting stress on the tendon itself. And when that tendon gets stretched too much, what happens? It causes it to relax. So we have two competing things here. We're getting a stretch reflex for my hamstring, and we're getting a tendon reflex. So if one is going to increase muscle activation and one decreases it, and they both happen at the same time, what's going to happen? Am I going to get an increase in the contraction, or am I going to get a decrease? And what we actually find is we find that your tendon reflex trumps your stretch reflex. And this makes sense, right? Because the tendon reflex is going to shut down the muscle before the muscle hurts it. So if the muscle contracts too hard, too fast, it might be okay because it's not going to tear, but the tendon itself is where you're going to get that rupture or that damage. And so your tendon reflex is going to trump your stretch reflex. I bring this up because when we're doing our static stretching, after about 7 to 10 seconds, so if I hold this stretch for 7 to 10 seconds, what happens is there's actually a desensitization, and part of that stretch reflex will actually start to go away because of that tendon reflex, because you have them both going on at the same time. So after about 10 seconds, you'll notice that you can actually stretch further than you could at the beginning of the 10 seconds. And you'll see this as a common technique, is you'll hold a stretch for 15 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you'll take a deep breath in. And as you exhale, you can actually go further into that stretch. And it takes about 15 seconds before you get that relaxation so you can stretch it further. So if you really want to get the most out of your static stretching, using this technique after you get that desensitization will actually increase how far you can go and increase your ability to stretch. So I would go 15 seconds, deep breath, as you breathe out, stretch a little bit further, 15 seconds, deep breath, stretch a little further, 15 seconds, stretch, deep breath, stretch a little further, and that'll get you about 45 seconds worth of that stretch. And you'll get much more out of that than just holding that initial position for the full 45 seconds. Now, we talked about the acute changes, and we talked in the short term, it can potentially help injury reduction if you have a major restriction, and it can facilitate some of that performance. But what about long-term changes? What about chronic adaptations, right? So we have the acute adaptations or short-term, and then we have our chronic adaptations, which are long-term changes. Well, what we know is that individuals who are more flexible have a lower risk of injury in sporting activities. So if you have restricted range of motion, you're going to be at a higher risk for injury than someone with good range of motion and good flexibility. However, the research is pretty clear that just stretching doesn't decrease your range of motion. Some of it has to do with some genetic properties. So if you're genetically predisposed to have good range of motion, that's going to help you not get injured the same way. Now, chronically, if you wanted to increase your range of motion and you wanted to help someone who maybe had a deficiency or maybe had a limitation, you would want to do about 3 to 4 days of this flexibility training to help offset that and help get that range of motion benefit. So training wise, 3 to 4 days seems to be the minimum amount you would need to cause some of those chronic changes. And it doesn't take a lot before you could get these. It might be as short as 10, 15 minutes each day, 3 or 4 days a week, before you would see some of those range of motion benefits.